Hey guys, welcome to today's class. Have fun.
So today we'll be considering the topic cycles, and my name is Amadi Solomon Chidebere. So looking at cycles, there are certain terminologies that one must know in order to be able to solve solutions or be able to make solutions to problems involving cycles. From the diagram here, you note that we have what we call the segment, and the segment is normally an enclosed space which is done by a chord and a circumference. The whole line you see here is called a circumference. Then when it's cut out in this form, it forms what we call an arc. So this line you see is an arc, whereas this is circumference. But this one you see here can either be a chord or a diameter. I mean a chord when a line crosses between 2 points on a circumference but not passing through the center of the cycle. So here what we have here is a chord, and an enclosed space by a chord and an arc is called a sector. So what we have here is a sector, whereas this is a chord, and then this, like we said, is a circumference. Why? When a line joins or touches 2 points of a circumference and passes through the center, it forms what we call a diameter. Then whereas when it stops at this point without touching the other side of the circumference, that it just touches a side of the circumference and then the center, it forms what we call a radius. So when you have something like this, and then this is the center of this cycle now, then a line crosses and touches this place, this is called a radius. But when it touches the other side, it forms what we call a circumference. So we have a diameter and then we have a radius here. And then when an enclosed space by a diameter and an arc forms what we call a sector. So what we have here is a sector, and a sector can also be formed by two radius. So we have one and then two. So this is the first radius, this is the second radius. So it forms what we call a sector. A sector. Sorry, there's a difference between sector and segment. When the line, this here we have sector is not a sector, sorry, it's a segment, sorry. So when a chord and a arc encloses a space, it forms a segment, whereas when a diameter or two radius and an arc encloses a space, it forms what we call a sector. So that's just the basic terms involving cycle. So the next one we're going to be going into another term known as a tangent. A tangent is formed by a radius and then another horizontal line touching the circumference of a cycle. So at what? Perpendicularly, when a radius and then a horizontal line is perpendicularly intersected, it forms what we call what? A tangent. So this becomes what? A tangent. This is a tangent to what? To this cycle. So that's some of the terms that is involving cycles. So the next one, we're going into some basic laws, and here we're going to be discussing 8 laws, or should we put it 8 angle properties. 8 angle properties of cycle. 8 angle properties of cycles. And it's very important that you have these 8 angle properties of cycles at the back of your mind, because this will greatly help you in solving problems involving cycles. So we're going to be looking at these 8 angle properties of cycle, and the first angle property we're going to be looking at is the angle which an arc of a cycle subtends. So the angle which an arc of a cycle subtends, we have a cycle here. So this is the center of our cycle. So this angle formed on a circumference, the angle formed on this circumference by, this is what we call a chord, by 2 chords, is 2 times the angle. The angle formed on the circumference by 2 chords is 2 times the angle formed by 2 radius at the center of a cycle. So this is 2 times, this angle is 2 times of this. So the angle formed by 2 radius at the center of a cycle is 2 times that formed by 2 chords at the circumference of a cycle. So this is the first law, this is the first angle property. And the second angle property, the second angle property is the angle in a semicircle. Angle in a semicircle is a right angle. This is the center of our cycle. This is a straight line. So what we have here is what? Is a semicircle. The first semicircle, the second semicircle. So any angle that is formed in any of these semicircles is always at right angles. If you have it like this, this is a right angle. If you have it like this, this is a right angle. So any angle formed in a semicircle is what? Is a right angle. Angle formed in a semicircle is right angle. So that's the second angle properties of what? Of cycle. And then the third one, is angle in the segment are equal. Angle in what? In the same segment are what? Are equal. Like we have in this diagram, if you can see it, this is what we have. We have something like this. So we have something like this. Then also, so when you look at this now, you get to understand that there are two segments here. This is the larger segment. That's if you divide a line, if you use a dividing line here, and then this is another segment. So let's say maybe for instance the center of our point is here. So any angle that are in the same segment are what? Formed in the same segment are what? Are equal. So the angle formed here is the same thing with the angle formed here, is the same thing with the angle formed here. So if you have 25 degree here, here can also be, here will be what, 25 degree, here also will be what, 25 degree. So that's the third angle properties. Then the fourth angle property, looking at a cycle, is angles in opposite segments are supplementary. So let's take, for instance, this is what we have in this diagram here. This is what we have in the diagram here. So if you look at the diagram here, we have something like this. Then also, so this is what we have, something like this. So looking at this, you get to understand that if we put a dividing line here, this is a what? A segment. This is a segment. Put a dividing line here. This is a segment. This is a segment. This is a segment. This is a segment. Put a dividing line here. This is a segment. This is a segment. You understand? So this angle and this angle are supplementary. This angle and this angle are what? Supplementary. So x and y are supplementary. P and q are supplementary. Supplementary in the sense that x plus y will give you what? 180 degree. Whereas p plus q will give you what? 180 what? Degree. So this is the fourth angle property of cycle. Then the fifth angle property of cycle is this, that when you have a cycle in this form, it follows that the exterior angle of a cyclic quadrilateral is equal to the exterior opposite angle. The what? The exterior angle of a cyclic quadrilateral. A cyclic quadrilateral. So this is a cyclic quadrilateral here. Cyclic quadrilateral is quadrilateral in a cycle. So this is a quadrilateral, and you know what a quadrilateral is. So this is a quadrilateral now, having 4 sides. So what you're trying to say is this, that follows that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. If you look at this quadrilateral now, with its line protruding outside, here and here are what? An angle on what? On a straight line. So what they are trying to say is that if you have here as x, this is the opposite angle to this. It follows that the exterior angle of a cyclic quadrilateral, the opposite exterior angle of a cyclic quadrilateral, the exterior angle of a cyclic quadrilateral, is equal to the interior opposite angle. So this is the interior angle of this exterior angle. So the interior opposite angle is this. So this and this, they're trying to say is what? Is the same thing. So that's the fifth what? Angle property. The same thing follows when you have a cycle in this form, and then you have here like this. The angle here is what? Is the same thing as the summation of this and this. So A and B, A plus B will give you what? Will give you this. So this plus this will give you what? This. So this will give you this. That's for this. So this is the sixth angle property. A plus B will give you what? The angle here. But here, x is the same thing as what? As this. So the seventh angle property of a cycle is this, and that is the tangent of a cycle. The tangent of a cycle is a tangent of a cycle to a cycle from an external point are equal in length. The tangent of a cycle from an external point, we told you a tangent is what? A line that touches the circumference and then forms a right angle with a radius. So this is a tangent. So a tangent to a cycle from an external point are equal in length. So this and this are equal. So if this and this are equal, which means the angle formed here is what? Is the same. So this and this are what? Are equal. These angle properties of cycle. So the last one, which is this a little bit more complex for students in trying to understand, but this is what I do to understand it when I have such, and most times it normally comes out in WAEC. So take for instance, they say the angle between a tangent, the angle between a tangent to a cycle and a chord through the point of contact is equal to the angle in the alternate segment. That's grammar. But if you want to really understand it, what that statement is trying to say is that if you have a line, a tangent in this form, and then you have a triangle touching this tangent, this angle formed here is the same thing as the angle here. And this is how I normally get it. Take for instance, you have this and this. This is formed in this manner. 1, 2, 3, 4. And it's normally backward. 1, 2, 3, 4. So the angle here and this angle is the same thing. 1, 2. The angle between the first and the second, and then the angle between the third and the fourth is the same. Angle here between the first and the second, the angle between the third and the fourth is the same. This angle and this angle are the same. So it can come in several manners. It can come in this form: 1, 2, and it's always backward. 3, 4. 1, 2, 3, 4. It's always backward. So you have it like this: 1, 2, 3, 1, 2, 3, 4. If you have it like this too: 1, 2, 3, 1, 2, 3, 4. So you see, so it normally forms an object in this form. So when you have it like this, so this angle here and this angle are the same. The angle here, y, and this angle is what? Is the same thing. So with that, we come to the end of this subtopic, angle properties of a cycle. Okay, so we're going to be solving some problems here. So we're looking at number 9, and also we are going to consider number 6 too. Number 6 and number 9. So from number 6 here, we have a cycle is drawn inside a triangle. So we have our triangle. So find out that a cycle is drawn inside a triangle ABC to touch the sides BC, CA, and AB at P, Q, and R respectively. So a cycle is drawn inside what? Inside a triangle A, B, C. So a cycle is drawn inside the triangle ABC to touch the sides BC, CA and AB at what? So at BC we have P, at CA we have Q, at AB we have R respectively. So if A is at angle 56 degree and B is at angle 68 degree, so if you find angles of what? PQR. So I've been asked to find the angle of PQR, which simply means what? There is also another triangle, so they asked to find the angles of this is triangle PQR. So I've been asked to find this and this. So from this diagram we can see that angle C is equal to what? 180 degree minus 56 plus what? 68 degree. We used 180 degree minus 56 plus 68 because it is what? Angle at what? Total angle of a what? Total angle of a triangle. So the total angle of a triangle is equal to 180 degree. So we have this. So if you subtract, it should be able to give you 56 degree. So if here should give you 56 degree, it simply means this triangle is what? An isosceles triangle. Isosceles triangle. So isosceles triangle has what? Two sides equal, one side different. We are not dealing on triangle. I'm giving you, we have different type of triangle. We have scalene, we have equilateral, but this is isosceles triangle. So that gives you what? 56 degree. So from here we can now calculate for BP. Can now calculate P, Q and R. So if here is an isosceles triangle, angle BPR is the same thing as angle BRP. So you get, so the same thing as angle BRP. So it's called that BPR is equivalent to BRP. BPR is same as BRP. How? Because what we have here is what? A scalene triangle, which means this angle and this angle is the same. This angle is different, which means this angle here and this angle will be what? Will be the same. Is that not so? This angle and this angle will be the same. If this one and this one is the same, this one and this one will be the same. Why? Because this is what? It's forming a triangle with it. So something like this. So this is a cycle. So we have something like this. So if this angle and this angle, this and this are perpendicular, this and this are what? Are parallel. Sorry, this line and this line are parallel to each other. So which means this angle and this angle is the same. This angle and this angle will also be what? The same, which is equal to also what? 56 what? Degree. So if here is 56 degree, here is what? Definitely will be what? 56 degree, which is angle what? their parallel angles. So that gives us what? 56 degree. So for if here is 56 degree, based on our 8th law, 1 2 3 4, 1 2 3 4, the angle between 1 and 2 and 3 and 4 are what? Are equal. This is a cycle. Is that not so? So we have a cycle there. So we have an angle here, we have another one here, we have another one here, we have another. So this angle 1 2 is the same thing with what? 3 4. Angle in between 1 2 is the same thing as what? Angle in between 3 4. So our PQR will be what? 56 degree too. And since our PQR is 56 degree, then our what? PQR is 56 degree, then our PRQ and RPQ are what? Are the same angle. Is that also? They are the same angle. It's also forming an isosceles triangle in there. This is an isosceles triangle, this is an isosceles triangle. So which means our RQPR is the same, is equal to what? QPR and QRP are the same, which is equal to 180 degree minus 56 divided by what? 2. That will give us the angle for each. So that gives us what? 4. And this is what? 180 minus 56 give us 4, this 2, so give us 124. So 124 divided by 4 divided by 2, sorry, 124 divided by 2 will give us what? 62 degree. So our angles are what? Based on this question, so find the angles of PQR. So PQR, triangle PQR gives us what? 56 degree, 62 degree, and what? 62 degree. 56, 62, 62. So this is the angle for what? For this calculation. So we'll go to the next question. The next question, which is number 9, in fig 15.51, express y in terms of x. So looking at this, we are being asked to express what? Y in terms of what? X. Express y in terms of s. So this is a little bit tricky, which means this should be expressed in terms of what? X. So this is a little bit tricky. So we'll draw a diagram. We'll just make a line here, a straight line to this. So we'll just assume that here is our B and here is our A. And also, then here remains our X. Then here we assume to be our C. So you get it. This is how the triangle is in here. This, when blown out, it's like this. So we have here as our X, we have here as our C, we have here as our B, and we have here as our what? A. So from here we find that what? B is equal to what? 180 minus s plus a. Is that not so? B is equal to what? 180 minus s plus a. So from here we have 1, then also 1, 2, 3, 4. 1, 2, 3, 4. So according to the eighth rule, A and C are equal. So just like I said, from here, since this is in a cycle, so let's put here as D also. So here should be D. So from here we discover that A, based on that our eighth law, for some of you who followed us from the beginning, you discover that our eighth law is that this 1, 2, the angle between 1, 2 is the same thing as the angle between 3, 4. So here our A is equal to C, whereas here D 1, 2, 3, 4, our D is the same thing as what? Our B. So if our here A is equal to C, D is equal to C, that means from here B plus S plus C in a triangle B plus S plus C is equal to what? 180 degree. So here B is equal to what? 180 degree minus S plus C. S plus C. So which gives us what? 180 degree minus what? S plus A. So it's the same thing, 180. So this is our equation 1. So this is how we got our equation 1. B plus S plus C. Since A is equals to C and D is equals to B, based on our eighth law, so we have that what? That 180 degree minus S is our what? Our equation 1. So Y plus C plus D, Y plus C plus D plus B plus A, B plus A will give us what? 180 what? 180 degree. That's for our equation 2. Angle in a triangle. These two are angle in a triangle. Sum of angle in a triangle. Sum of angle in a what? Triangle. So you get. So from here B is equals to what? 180 degree minus S minus A from this equation 1, and then Y. Then from here, if you open the bracket, we now have Y plus what? Y plus C plus D plus B plus A is equal to 180 degree. If you equate,
you are mighty on your throne.
so Y plus C plus D plus B plus A equals to 180 degree. So but from our equation here we have that A, which is equals to C, and D, which is equals to B. So from here we now have that Y plus C becomes what? A, whereas D becomes B, then plus B plus A equals to 180 what? Degree. So from here you can have that Y plus what? Y plus, you can now have that 2B is equals to 2B is equals to what? 180 degree minus Y. If you carry Y to the other side, 2B minus what? 2a. Is that not so? So from this equation now, divide both sides by 2. So divide both sides by 2. So what we now have is, okay, divide both sides by 2. So b, we now have b, which is equal to 180 degree minus y minus 2a over what? Over 2. So you equate this one, you equate this equation into this one, it will now give you, since b is this, you now have 180 degree minus y minus 2a over 2 is equal to 180 degree minus x minus a. Is that not so? So the next equation this gives us is this. So from here we have that 180 degree minus y minus 2a is equal to what? 2 into this will give you 2 bracket 180 degree minus x minus a. So from here you have that 180 degree is minus y minus 2a is equal to 360 degree, 2 times this, minus 2x minus 2a. So from here you have that, from here you now have that y is equal to, you take 180 to this side, come 360 degree minus 180 degree, then minus 2x, you understand, minus 2x, then minus 2 minus 2a, so is minus y, so 180 minus 360 minus 180 minus 2x minus 2a plus 2a. So 2a minus 2a plus 2a will cancel. So we are now left with what? We are now left with y, which is equals to this minus will now multiply both sides. So when you might multiply, to remove this minus, you multiply minus here, you multiply minus here. So here becomes y, which equals to, here becomes minus 180 degree, because 360 minus 180 is 180. So minus 180 plus 2x. So that gives us 2x minus what? 180 degree. So this is the equation. So we now express y in terms of what? X. So this is the equation. So y is equal to 2x minus what? 180 degree. So that's that for this what? Equation. So we'll just solve one other WAEC equation, and then we call it the end of the topic. So we are going to be looking at some WAEC equation. If we go to WAEC 2012 part 1 3a and number 20, 2012 objective core number 20, and 2012 and AC part A part 1. So you go to 2012 objective, you have this number 20, 2012 part 1 AC, you have 3a, you have this. So we'll solve for these two. So solving for this, we are asked to, in the diagram TU, the diagram TU is a tangent to the cycle. I thought that was what tangent is. So KV RVU is 100 and URX is 36 degree. Calculate the value of angle STU. So you are calculating STU. So you are calculating this angle here, X. So you understand. So, and this is how we're going to go about it. So 3a. So this is how we're going to go about it. So we are looking for xt what? STU. So we're looking for STU. But from this diagram now, we have that RSU plus RVU, RSU plus RVU is equal to what? 180 degree. From our fourth law, some of us will follow from the beginning. If you watch from the beginning, from our fourth law, angle in two different segments are what? Supplementary. So we have RSU plus RVU to be what? 180 degree supplementary angles. So from this, we now have the RSU is equal to what? 180 degree minus what? 100. So which means RSU is equal to what? 80 degree. Is that not so? So furthermore, we have that SUR is equal to SUR is then equal to 180 degree minus 80 plus 36. SUR is then what? SUR is 180 degree sum of angle in a triangle. Sum of angle in a triangle. Since you have here as 80, so SUR is 180 minus 80 plus 36, which gives us what? 180 degree minus 116. So our answer becomes what? 64 degree. This is sum of angle in a triangle. Sum of angle in a what? Triangle. Sum of angle in a triangle. So that is us 64 degree. So if that becomes 64 degree, so hence TSR that which is here TSR is equal to 100 degree. Agreed. Based on our fifth law, which says exterior opposite angle are what? Exterior opposite angle are equal. So from here we have that what? 100 here becomes what? TSR. So our TSR is here now. So exterior opposite angle are equal. So here, based on this, so this is the opposite angle, which is what? 100. So from there we have our TSU so not TS, yeah, TSU TSU is what? Is 100 degree based on our fourth law, which exterior opposite angles to interior opposite angle is what? Is equal. So from here, this is the opposite angle, but the exterior opposite of this is now what? Is now 100 degree. So here is 100 degree. So our TSU is 100 degree. But TUS is what? Is equal to 36 degree based on what? Our eighth rule, which is 1 2 3 4 1 2. The opposite, the angle in between 1 2 and 3 4 is what? Is the same. So here our TUS is what? 36 degree. So if here is 36 degree and here is 100 degree, so our STU is now what? 180 degree minus 100 plus 36. 100 plus what? Plus 36, which is total angle in a triangle. So that gives us what? 180 minus what? 136. That gives us what? 44 degree. So this is the solution to this problem. So for number 20, we have that in the diagram, O is the center of the cycle PQR, and this angle PSR is 86 degree. If angle POR is equals to S, find X. So we are being asked to what? Find X. So from this, PQR POS, which is equals to X, based on our first law, based on our first angle properties, angle properties of cycle, angle at center, angle on circumference is 2 times angle at center. Is that not so? Angle at center is 2 times what? Angle on the circumference. So X is equal to what? 2 times our angle. Check it. This is the angle of center, and this is the angle of circumference. They were a little bit tricky here, in the sense that they didn't put the normal way we normally do, where you have the center here, you have something like this, and then you understand. But this time around, they move it at this. So this angle is what? This angle is 2 times angle at circumference, which is 2 times what? 86. So angle at center is 2 times angle at circumference. That gives us what? 172 degree. So 2 times 6, 12. 2 times 8. So, and if you see 172 degree, that's the answer for this problem. I think that brings us to the end of cycle. My name remains Amadi Solomon Chudebre, and thank you for watching. So just make a comment. If you have a question, put it on the comment section. If you have a recommendation, put it on the comment section, and please don't forget to like our video. Thank you.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.